So, talking about the multiple choice part B. Talk about number one. Number one, it says, what is the average rate of change of f over the closed interval from 1 to 4? Average rate of change just means slope. Okay? So when they want to know from 1 to 4, we're going to take and do at 4, the y value is 10, minus at 1, the y value is 16, over 4 minus 1. So 10 minus 16 is negative 6, 4 minus 1 is 3, negative 6 divided by 3 is negative 2. Rate of change just means slope. Okay. So number 2 we talked about yesterday. That was putting it in your calculator under quarter Craig. All right. How about number 3? Were we good with number 3? Okay. For number 2, it is B. Okay. Do you want the quartic reg? For number 2, you're just putting it in list 1 and list 2. Yep. And then you should get y equals 0.0036 x to the 4th minus 0.0833 x to the 3rd plus 0.6898 x squared plus 0.583 x plus 1. Yep, then you plug in 18. So if you put it in the list, you go chat again and you go to calculate, right? And down to quartic reg. Quartic reg? It would be, yep, found it? Okay. Well, these are pretty small decimals I have up here. Okay. All right, number 3. Number 3, it just wants to know, it talks about all the different points that are labeled. And point C is the point of inflection of the graph. It wants to know of the following, on which intervals is the rate of change of G decreasing? So where is it getting the rate of change getting smaller and smaller and smaller, or less and less and less? So on number 3, yeah, it's between C and D. As you can see, it's as it's coming up to its peak, it's getting less and less, right? And then the other one, it goes from D to E. Well, C is your point of inflection. Is that what you're asking me? Yeah. So when it comes to your point of inflection, that's going to be the steepest part of your slope is right there before it starts changing again. So when it goes from like B to C, the slope's getting more and more and more and more and more. It gets to C and the slope gets less and less and less and less and less. So like the A to the B, isn't that less? Well, you know, it says it starts off, yeah, it is getting less and less as it gets to B. Well, let's see what their reasoning is. Shall we do that? Let's see what they say. So let's just, I'm going to move you out of the way for a second. That's not the one I want. Just a minute. Into here. Now let's see what their reasoning tells us. So I think we did, pretty sure it was this one. Alright, so here's what it says for this one. It says that D is correct. It says these intervals in which the graph of G is concave down because the rate of change of G is decreasing. They said C is incorrect because these intervals on which G is decreasing. These are the intervals on which G is decreasing. The graph is concave up because the rate of change is increasing. Okay? Yes. Okay, that's their reasoning behind it. All right, moving on. Number 4. Did we talk about that one yesterday a little bit? Yeah. Yes, the correct answer is C. Okay, so should we get on that one? Number 5. The set of data is represented using a semi-log plot, on which vertical axis is logarithmically scaled. The points of the semi-log appear to follow a decreasing linear pattern. So anytime we're talking about a log or a semi-log plot, they like to put them where they look like lines. If it's decreasing, then it's going to be an exponential decay. If it's increasing, it's going to be an exponential growth. Okay? Log and exponential go together. Number 6. No. Number 5 is C, exponential decay. Remember when you're trying to get rid of log? Is it D on the back? Oh. See, I'm wrong too. All right. It says C. Don't look at 5 at the top. Remember, this is at the bottom. The 5th one down.
Oh, so this is 80.
Yes, this is 80.
Oh, okay.
Okay? Yeah. It just happens to be C. So then 5 is C. If it was in exponential. Yep. Absolutely. On number 6, they give you this C of X equals, right? Let me get out here. Number 6. And they want you to find the rate of change, which means slope, from 30 to 40. But in order to do that, we need to figure out what the B is in the equation. C of X equals 1,000 plus BX over X. And they start by telling you it is known that the cost is 115 to produce 10. So we're going to put 115 in for like the cost part, and we're going to put 10 in for the x. All right, so I have 115 equals 1,000 plus 10x over 10. Or not 10x, bx. b10. That's what I'm trying to say. Oh my gosh, sorry guys. Because we're solving for b. Whew. So I'm going to multiply my 10 over. So I have 1,150 equals 1,000 plus 10b. Subtract 1,000, I get 150 equals 10b. So b equals 15. So now we can use this equation to do our slope. Okay? Because we now know what b is. We know c of x equals 1,000 plus 15x over x. And it wants us to find the slope from 30 to 40. So I'm going to write it like this. We're going to do f of 40 minus f of 30 over 40 minus 30. So first we're going to plug 40 in. So 1,000 plus 15 times 40. 15 times 40. Let's see. Yeah, 600, so we get 400, right? Or 1,600 divided by, I'll plug 40 in here. We'll do that again. I get 600, so 1,000 plus 600 divided by 40 is 40. Thank you. 40, right? So I get 40 minus, now let's plug in 30. So that should be 1,000 plus 450. So 1,450 divided by 30. At 48 point. Okay. Yeah, because you do have a calculator for this one, right? Yeah, divided by 10. Yeah, negative. Yeah. Yes, it's negative 0.83. We can't keep going because it is money. Yep. Yep. Yes. The x value is 40 minus 30. All right, let's talk about number 7. How do what? Go ahead. Yeah, so on the problem, it wanted you to find the rate of change from 30 to 40, where x equals 30 to x equals 40. So this is the change in y, right, the y values over the x values. Okay. Parentheses? Yeah. All right, number 7. Talk about what number 7 is actually asking you to do. It says, it gives you this equation for the number of hours t, where t is measured in hundreds of people per hour. Which of the following gives the time t and reasoning for when the number of people inside the shopping center is at its maximum? Okay, so here's what the easiest thing to do is. We're going to graph it in your graphing calculator. Grab your graphing calculator and graph it. Yep. Yep. So here's what we need. If we want to know when it's a maximum, we need to find the zero of the function where it goes from positive to negative. So we want this zero right here. Yep. Second and trace. Go to your zero. Yeah, left bound, right bound. You should get x equals. Yep. Okay. So then when you're looking for the reasoning, it's a maximum because when it's positive up here, it means that it's increasing. And when it's negative here, it means it's decreasing. So it goes from increasing to decreasing. It's a maximum point. That's what it means. Okay? So this one is letter D. Yep, 8 is still C. We're good there? Yep. It has to, yeah. Oh, you can. Or if you just look at it, it's up to you. Yeah. All right. Are there any questions on 9? Okay. Let's talk about 9. On 9, it gives you some values. So instinct should tell you you're probably going to need to put it in your stat. Yep, list 1 and list 2. Okay. So in this one says predicted by the logarithmic function. So when you go in there, the one you need is natural log reg. There should be an ln button, like an ln reg. Okay? So when you put it in, we should get hopefully. Right, and you're just plugging that in. Typing that all back in your calculator. And hopefully it gives you 5,345. Yeah. Well, no, go into stat and go over to calculate. Sorry. Stat, calculate. And go down to natural log reg. ln reg. Yep. Yeah, because it does say in the problem. Yeah, to the nearest pound. Yep. Yep. Number 10. Number 10, as soon as you see theta in there, you should know that it's probably polar coordinates, right? It says a polar coordinate system. So you can change your calculator into polar and plug in this equation is one way to do it. If you do that, for number 10, I think you get a graph that starts here, swirls around, and comes out like this, something along that line. So it actually comes back to this center a couple times. So what we need are those couple of points where it comes back to the center. Okay? So you can either do your zeros, like in your calculator, go intersect, or the other way to do it is I did it with a table. So, or you could actually just move your cursor back here because you look at it, the first one starts here, if you put your cursor there, and we should get 0, and I think the decimal is 2.094, which is actually 0 and 2 pi over 3 if you use the table. The second one where it comes back to 0 is at the point 3.142 and 4.189. which is actually pi, and I think this is 4 pi over 3. You're struggling to find what, Jordan? Okay. So did you graph it?
Yeah, I picked graph.
Okay. So one way is to do it, you can go second trace. Oh, that didn't work. I'm sorry. Second, get back out of that. My bad. All right. If you're just in there. Yeah, so you want to go 0.
0?
Yep.
Where x is equal to 0?
Yep.
Alright.
Okay, so now follow your graph around. So keep pushing that till it goes.
This?
Yep.
This is
Oh, hold on. Let's try. Yeah, yours isn't on your graph for some reason. That's very weird. Very weird. I don't know why yours is doing that.
the only things that have changed are the background.
Yeah. No, let's see. So let's try this. I'm going to try, we're going back to value. We want to know when it's at 0, so I'm going to plug in 0. We get x is 3. That's not where we want, right? Okay, but then as we do a table, one of the points I got is again, if we go second in value, if I put 2 pi, actually let's use 2 pi. Oh, that didn't work either. What the heck is going on?
That'll be fine. During the time,
I don't know.
I'll probably have to use one of those calculators anyways, so.
That's really weird. Did you guys get the values to come up?
No, how do you do it?
Okay. Well, how about if I do it on top up here? What? Well, first of all, this is polar. So we're going to go to polar coordinates. You got to go into your function or into your mode and change it to polar. And second, quit so you can get out of that. So you go into your y equals. And we've got r equals 1 plus 2 cosine theta. Then you hit graph. Yeah. So you get this little picture up here that happens, right? This one right here. Are you in radians? I know how to do it now, Jordan. I'm sorry. Try just hit trace. Yeah, see how it's now move it one way or the other and see if it goes around. There we go. Okay. Oh, because your Windows. What the heck? Oh, look at your Y values. Somebody's got them in the 2000s. You're in degree. You have to be in radian.
I wasn't radiant. I still got those squares beginning.
Okay, so now I just want you to hit trace, and then you can move your cursor around, hitting it to the right. Where is your cursor? Well, it's way up here. We got to get it. There you go. Now hit trace. Now just see your cursor. What the heck? Go that way. I gotta get you back somehow. Right here. Okay. As you push around, you're going to push to the right and see how it follows your circle around. When you get to the 0 or where it intersects the y-axis, that's the 2 points we want. Yes, sir.
Hot dog?
Sure.
Hamburger meat? They didn't have any, I don't know, they cooked more hamburgers than there was buns.
I'll steal a hot dog. Thank you.
You're welcome.
So it should keep going around. It should come back to it again. See how it like... All right, let's do it a different way. Let me show you. We'll do it a different way. Because I just followed my little cursor around, and when it got to the same point right here, we're looking for where it intersects the like. It starts right here, and it circles around. So every time it comes back to this point, that's what I'm looking for. I'm coming. Yeah.
I'm like 90%. I'm like 60% of the way.
All right, so your window. Oof. Oof. Let's see if we do this. Did you? Okay. Well, what's your y value when it's 4.1? You know, what's your y value when you're at pi? What? You didn't put the whole thing in, silly. It's 1 plus.
Oh, yeah, that'll make a difference.
Yeah.
That's on me. Everyone else was having issues. I just assumed it was fun. All right, there we go.
All right.
That works.
We're good?
That's right. Yeah.
We're good? Yeah, that's right. Okay. Okay. Number 11. Number 11.
They're magnetic.
Oh, absolutely.
I thought maybe
Yeah.
instead of having everything in a...
Yeah, thank you. All right, let's talk about 11. Maya, as you're listening to this, we're having like discussions and working on the calculator. All right, number 11. It gives you an equation. We are going to type that equation into our calculator. It wants to know at what time did person number 4,000 enter the museum. Now, oh yeah, you got to go back to function. You still want to be in radians because it's a trig function. Okay, now here's the important thing. In the first y equals, you're going to put that equation. 4.217, tangent inverse, you're going to type that all in. It should give you a graph that kind of looks like this. Okay, the second y equals, we're going to put in the number 4. Because it wants us to do 4,000ths, the 4,000th person, and it's in thousands. So we have to do 4. So we're also going to put in y equals 4. So we're going to get this line at 4 that comes across. So then we just need to know where this intersection point is. What is the x value when y equals 4? No, you do first equation, second equation, guess is enter. I'm sorry, what, Libby?
How do you find the
The intersection of this? Okay, you're going to go second and trace. Go down to intersection. Yep. And then it's going to say first graph, and there's a little cursor. You want to move the cursor close to where the intersection is. You hit enter. It says second graph. The cursor should be on the line. Hit enter, and hit enter one more time. And should jump to the intersection point. Yep. So this answer is B. So the spot right here was at 2.029, or round up to 3. It is B.